big lessons seem to be size as a limiting factor to kill a project. I think you mentioned there was a problem with heat distribution.
Right. Yeah.
What were some other things? What were the big lessons?
So the size, we were just, you've sort of heard it said here and there that, like, you know, you can't try to be like Apple if you're like a little startup company, and you know, I would definitely point that out. So we tried to make like the most ambitious, like perfect small device possible, and you know, every millimeter counted, and we were loath to make it any bigger because we just wanted it to be tiny, and with that comes kind of a, you know, cascading bunch of problems and challenges. So this thing is kind of a powerful computer, and it gets hot, and the heat has to go somewhere, and there's batteries inside, and batteries don't like to get hot, and when they do get hot, they explode. And if you want somebody to manufacture this, they don't want to manufacture something that might explode, because that's on them. And so no matter you know, what you think, if you want to have a factory building something, like, it has to work to their standards, otherwise they're not going to want to do it for you. So just the basic issue of thermal engineering with cameras is you know, very real and very serious, and that's not something that we took into account properly when we started building this. And the camera worked, but it got just like really hot. And that, you know, that affects the image quality. The image sensors don't like to get hot because they have increased noise when they're hot. The lifetime of the circuit boards, PCBs, and silicon is shortened when it's hot all the time.
I mean, these are all things I would never consider as a software guy. As a software guy, like, I worry about network requests not arriving and things like that. And
yeah.
There's different complexities. But to think about heat distribution and like the physicalness of how this thing exists in space, just way beyond me. And then you have the complexity of photography on top of it.
Yes.
Like, this is like peak level engineering.
Yeah.
This isn't just like, you know, I always think they call software engineers engineers. And in my experience, there's engineering that happens, but coming here and seeing this and having been in hardware spaces, it's like, wow, this is actually a lot of different sort of engineering. This is like, as a kid, what I thought engineering was. And
right.
Software definitely has complexity, don't get me wrong.
Yeah.
But I have a different appreciation for how hard it is to pull off something like that or something like this. And you meet the teams and what they're thinking about. They're just so different than what you think about as a software guy.
Right.
And it's fun.
Yeah. And yeah, the other major lesson that I learned from this was that we had a working prototype in the very beginning when we first did the Kickstarter, and it was big, it was like really ugly, it barely worked, but it was a minimum viable product that people would have bought, and we could have sold the prototype, which was nothing even close to this in terms of the, you know, beauty or size or anything, but it did work. And we didn't sell that, and we put another 1.5 years into building this thing before we shipped anything, and that was the first kind of original sin. And yeah, there's nothing wrong with shipping something that is not 100% perfect. In fact, if you wait until it's 100% perfect, you're, you know, possibly going to run out of money.
And so that company closed.
It ran out of money.
What happened? How did, like, run me through this? I know that you'd mentioned that something about the camera sensors being special on these, and the thing I got from our beers last night is there's essentially a rebirth story here. Mm-hmm. You didn't give up on this dream of building photography hardware.
Right.
Walk me through the steps. How'd you go from this to this?
So yeah, we can show them side by side for a minute. So there's kind of a major difference here in the size. There's, you know, there's obviously differences in the functionality and the basic specifications too, but few of the major lessons. If you're going to build some extremely complex device, you don't want to make it even more complex if you don't need to.
Okay.
Like, if nobody really cares too much how big it is, then it will be massively easier with much fewer problems, especially fewer kind of unknown unknowns if you just allow the device to be a bit bigger. Like there's, in terms of the PCB design, the electrical engineering, the signal integrity, the heat. There's just so many things that, when you miniaturize it, they become, very severe challenges that require some, really serious engineering to overcome, and a lot of just, testing and iterations that are unavoidable. And, if the device doesn't need to be that small, then my God, like don't do that unless you really do know what you're doing.
Yeah. So the Sphericam weighs what? Would you say it's half a kilo?
Yeah, well, 400 grams or something like that.
Okay. And then this one weighs how much?
That was about 4.5 kilos, so it's like 10 times more.
And same number of image sensors? More?
Well, it's the same number of image sensors, but they're higher resolution.
Okay. So walk me through what the progression was between going from that to this. Like there's some story there of a founder that your company didn't survive. So you walk through that. How did you pull yourself up from the bootstraps and move to this?
Okay, so
there was a big lesson there.
Yeah.
You had an object that was a prototype, and then now you had did you do something even different the second time?
Yeah, so the design of the product and the use case was different. So the customer was different. That resulted in different specifications and different requirements to design it and build it. So
And did you get buy-in from customers ahead of time?
I did. So at the end of Sphericam, we were talking to like the Google Maps team, for example, who have wanted to be able to use third-party cameras and to allow normal users and third parties to generate Google Street View imagery and publish it on Google Maps. Yep. So they wanted cameras for that, and they wanted to have cameras that are approved that anyone can buy and anyone can use to publish Google Street View imagery. So there was a set of basic kind of specifications and requirements for cameras that could be used for that. So I took that into account and talked with quite a few people in the Google Maps team about how that product would look. And I was also in touch with Mapillary, who have been acquired by Facebook since then. I became friends with Jan Erik Solem, the co-founder and CEO of Mapillary, who's one of the more knowledgeable people about user-generated mapping imagery and kind of crowdsourced street view types of data capture. They were using primarily dash cams at the time, but they wanted to explore using a more kind of dedicated, purposefully designed street view type of camera. So I got a lot of input from them on what they would like to see in the product. So got some specific guidance from specific future customers about what the product should be. And it's a very narrow use case. This, having a camera on top of a car and making images of streets. It's not, Sphericam was like a kind of generic VR camera.
Right. You
want to shoot 360 video of anything you want, then you can get a camera for that. But this is not, a generic camera. It's, for this one specific use case, and it's supposed to do just one thing well.
Yeah, it's like I see this, and I often tell my team in software, there's sexy engineering problems, and we like to solve those.
Yeah.
But are they business problems?
Right.
And if it's a sexy engineering problem, but it's a solved problem and someone else has solved it, maybe we just buy that software instead of trying to engineer it ourselves.
Yeah.
This looks like a really sexy engineering problem is probably the hardware corollary to that.
Yes.
A bunch of really smart engineers wanted to build something cool.
Yeah. And
this is cool, but it solves a business purpose.
Right.
So for mobile mapping, people know Street View, but what do people do with the cameras?
With these cameras?
Yeah, with these cameras. What are their use cases? What are the ones you can talk about?